Welcome back to Python programming from beginner to programmer. In this segment of our discussion on database essentials, we are trying to learn about more complicated ways to perform filter for to achieve our goal of selecting only those rows. And how do we describe those rows? How do we achieve that business goal of obtaining that piece of information? So, and what we want to also learn at the same time is how do we organize data? How do we model the storage of data in database? So, a lot of times in our data storage, we find that the occurrence of certain groups of data, they are very static. They don't change a lot. But another group of data uh, changes a lot, gets expanded very rapidly based on our business activities and so on. So one quick example, and by no means it's just this, one quick example would be people, right? Customer, could be members and customer people. So customer, their names and address, they don't change frequently. I mean, people do move around, but they don't change their names. When your customer base get very, very large, yeah, some portion, some small percentage of people might still change their names. But, that cannot be the bulk. Most people may change their address, but it's not a monthly or weekly exercise. It's not even a annual kind of basis for most of your customers, I would say, right? So it's pretty static in that sense. Now, of course, static is relative because if everyone changes their address um, every 2 years and you're talking about 100 years, then that's pretty frequent also, isn't it? So static is kind of relative to, say, transactions, where the customer or customers will come to any of your branches. Maybe you're doing a retail uh, chain, and the same customer having the same membership number will come to any of your branches and buy stuff, maybe even twice or even 3 times a day, right? So if you're running gas stations, and again, that would mean maybe weekly basis, and that is certainly much more frequent than annual change of address. And I'm just using it very in a sort of very extreme manner. People don't necessarily, or at least the bulk of your customers don't move house every year, like as if it's a sure thing. So in this case, what we want to do is not to repetitively store the same customer, Kate. Um, Kate 12 One Road. So she had a lunch for four at Takashimaya for $128.50. Then we also store her name, Kate, and then her address, 12 One Road. And then she paid 85.77 for dining. Again, her name is Kate at address 12 One Road, and so on. So that would unnecessarily, burden the database by having a lot of repeated data. That's one, and a lot of almost, multiple storage, and therefore taking on extra unnecessary storage space. You might say also that the storage cost has come down a lot, and I totally agree. And computer speed of processing has gone up a lot. I totally agree. But also, this would slow down the search of any particular customer because all customers have bloated data. All their transactions have multiple copies of their addresses and names. And so when you search, the server, the SQL server, will have to do a lot of, no matter how fast the CPU, it still has to do a lot of filtering and ignoring. When you ignore, it's an active ignore. You have to see first, that's not the data I want, then drop it, right? So there's extra burden in search. What that means is instead of having a very dynamic and active and reactive kind of website, people click search and they find a dining menu and membership information and so on. It becomes a slow spinning wheel because your server is still spinning. It has to, you know, retrieve the data, realize that it's not the customer I want, and ignore the data. So for many reasons, other and despite actually, despite the drop in cost of storage and increase in speed of processing, we still want to organize our data in a way that helps the computers to process the data, to search, to add rows, to delete, and so on. So the way to help is very simple. Group the more static data in one table, and there's a little bit of an art and trade-off and balance there that needs to come with a bit of experience. So as a start, it's quite common practice to put customers as a table, and when you need to change your mailing address, you change it in the customer table without affecting the historical transactions or future transactions. Yeah, right. And also in the transaction data table, it will store the sort of the records that are frequently being generated, frequently being deleted, frequently being accessed. So you kind of group them by frequency of access. Another way to think about it is also what is mentioned here, is their occurrences. So for instance, transaction database, the transact here, the table here, links to or uses the customer ID. Because we say, who paid $55.20 for dining at Orchard? Oh, that's customer ID 2. Customer ID 2. That, who is that? Oh, when we then point to, then we refer to customer table, it is actually Bill. And where does Bill stay? He stays at 4 Orange Road and so on, Orange Street, right? So in this manner, we are always able to still retrieve back Bill's information, but via a pointer, via a reverse pointer, because the 2 here is actually an address or an ID, telling us address in the sense of the database address, telling us where to find the customer's name, which is Bill, his address, which is 4 Orange Street. It's very clear. But the customer table, on the other hand, doesn't point back to transact. So we do not actually, we wouldn't be able to know what Bill might in future spend at which place, at which of our branch, restaurant, and so on. So the the references will be the way to also segregate the data into different tables. So when we use customer ID here, that means we store number 2, but 2 points to the ID, the primary key value in another table. Then this customer ID in the schema of transact table is called the foreign key. It's called a foreign key. Why? It is not a primary key because in transact, it has its own primary key. This ID2 here in the transact table refers to the second transaction in the table. It's got nothing to do with customer. But the customer ID value 2 has a meaning. It is not to be interpreted on its own. It has to be interpreted relative to the primary key of the customer table. I think that much is quite clear when we do it in daily lives. So when we digitize it this way, there is a new term involved, and that's called primary key and foreign key. So primary key defines, foreign key uses, as simple as that. A lot of students, when they were first exposed to this, found it very confusing because their keys, yeah, I know, and they need to be unique, I understand, but why can foreign keys be duplicated? And what if I call this ID? Can I call this ID? You cannot, because it will clash with this ID here. But what if the primary key is also called customer ID? Is that okay? Yeah, that's okay because it's in another table. But can the two IDs be different? Primary key is called ID, foreign key calls it customer ID or CID. Yeah, that's possible as shown here, right? So they this concept of primary key and foreign key might sound confusing. Actually, it's not. Primary key defines, foreign key uses. Obviously, you cannot use something that's not being defined. So there has to be a primary key somewhere. So foreign key just uses. Now, in the bigger scheme of database, when you mark this column to be foreign key, you are also able to say something like, for example, delete when there's a need for database to delete Bill because Bill decides to quit membership, right, or whatever it is. Delete Bill, right? Delete ID2. It is possible to pre-program the SQL using the schema of transact to say that whenever the primary key is deleted, all the foreign keys rows, all the rows having 222 here, all will get wiped out as well automatically by the server and do it efficiently. So that's nice. However, having said that, I'm not going to discuss that because I also tend not to want to encourage you to use it because I don't like to have the SQL Server do so many deletion on its own. I would rather programmatically look for the rows that need to be deleted and then decide whether it is the right time to delete or should archive first before I delete or should ask user first before I delete or to do whatever. So even though conceptually we know this column is called a foreign key, conceptually, I don't encourage you to program it into the schema to say whenever primary key that this foreign key refers to is deleted, then delete this, So something just for the safety of the data, uh, don't let the server decide too much on how it does things automatically. Okay. So that's just a word of advice. But if you know what you're doing and you insist on doing automatic kind of thing because it's just your personal hobby project and you like to just automate it as much as possible, then certainly. So long as you know what you're doing, that's fine. So having said that, how do we get it to work? And what do you mean by cross-referencing tables? So the idea is that when we separate the tables, or rather the data into two tables, right? The primary key table and the referencing table like transact, we need to join them conceptually. So when we say join, yes, we even draw it out as being fused together, right? Physically, but SQL Server kind of only does it logically. So the data is not being physically moved together and then disassemble again, So that would be super, super slow. Imagine having gigabytes of data like that. So what we are discussing here about joining is also is only a virtual joining, logical joining. All right. So to us, when we say join and we physically paste them together, it seems easier to understand why. There are two kinds of join, um, cross join or outer join versus inner join. Okay, so cross join basically is like union the two tables together, providing all combinations of rows, all right, with each other row. So all possible combinations are being sort of spelled out or laid out in this temporary joined table. Versus inner join. Inner join is not shown here, but we'll discuss in a few slides now. Inner join is intersection. So union, intersection, very simple, right? Cross join, union. Inner join, intersection. So the in means intersection. Just think of it that way. So cross join came from the word cross product or Cartesian product, meaning if I have 1, 2, 3, and 4, 5, 6, then I will pair them all together. The outcome is 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. All possibilities, like a grid. Yeah, like a grid. But a grid is laid out in terms of a lengthened table like this.